This is Khalil Nassar with the Rokroot online debug training series. This is Concepts, State Manipulation, and Relativity. This module introduces the concept of illusion. Given a finite set of resources, present the illusion that an almost endless set of resources exist. Consider a hypothetical computer with a fixed amount of RAM and one microprocessor with a fixed set of registers. This computer has no operating system, is capable of reading and writing to every address in RAM, and begins executing a single stream of instructions when an address is written to the instruction pointer, which is a register or storage location within the microprocessor. At this point, we don't really have the concept of a process or a thread, but rather a machine that can do only one thing. The instruction pointer is loaded with an instruction address, and the microprocessor begins decoding and executing instructions. Next, we want to add a timer to this computer such that when the timer expires, all the microprocessor registers are stored in a unique section of RAM. And a different instruction stream is initiated by writing a different instruction address to the instruction pointer. When the timer expires the second time, again the microprocessor registers are stored to a unique section of RAM, but this time the original registers are loaded back into the microprocessor, including the instruction pointer where original execution left off. This continues back and forth, where each unique instruction stream gets the computer resources, executes for a fixed amount of time, is stored, and then the other unique instruction stream gets the computer resources and execution time. Here we have a simple example of a system with multiple execution contexts. In this example, both execution contexts had access to all of the RAM. In this example, state is defined by the microprocessor registers and the entire system RAM. Now we flash forward to a modern operating system such as NT. The concept of state is much the same with a few additional complexities. Namely, we have the process container whose main purpose is to carve out a unique area of memory for its defined set of execution contexts. Also, the execution context itself is much more sophisticated, tailored to survival in a high-speed asynchronous environment. State is the definition of an execution context's world. I want to now define the thread as an execution context with storage for all the necessary state to define its world. Its world includes the microprocessor registers, the memory it has access to, and a record of its interaction with shared system resources, such as peripherals for storage and network. A process is a container or data structure that holds the key to accessing a chunk of unique memory, and also is the keeper of its own group of stateful execution contexts that have access to only that memory. The key to a process's unique chunk of memory is the directory base. At this point, we can define the granularity of state. At the outermost level, we have the directory base, which defines the memory view. At the next level, we have the thread, which defines the execution context. And finally, we have the scope of the thread, which defines the finest grained detail of what a thread is doing at a given moment. State manipulation is how the operating system is able to multitask, i.e., share a common set of resources from multiple execution contexts. Relativity dictates what the debugger sees. The debugger is able to maneuver to a process of your choosing, threads within the chosen process, and then scopes within the chosen thread. As we will learn, from the kernel debugger, a process can be selected with the .process command. A thread can be selected with the .thread command, and thread scope can be selected with the .frame command. We use the same concepts in setting debugger relativity as the operating system uses to change state: process, thread, and stack frame. These are the three basic levels of relativity when debugging. In conclusion, Having a basic understanding of how the operating system virtualizes hardware with the concept of state, stateful execution contexts, allows the debug engineer to use the debugger to maneuver through the system at will and analyze all necessary information. This understanding is also crucial for kernel mode and user mode code development. Thanks for studying with Module 2, State Manipulation and Relativity.